In this lesson, you'll learn how to create a line plot. What is exactly a line plot? It's basically a diagram that shows the frequency of data on a number line, or how often that data occurs. The parts of a line plot. There are 5 parts to a line plot. The title. So if you look at this example of a line plot, you can see the title is Video Games Owned by Students. So I did a survey to see how many video games each of my students owned. The data, so I go around, I collect the data, and I plot it onto the number line, and you can see those X's. Then of course you have to have the number line, since it is called a line plot. You have your number line, and you'll notice it doesn't always have to start at 0. It just starts at the smallest piece of data to the largest piece of data. You want to make sure to have the range from what exactly your data shows. You have your label to label what those numbers mean. In this case, it means the number of games. And of course you have to have a key. Each X will represent one student. So each of these X's represents one student. And I like to think of it as a little person standing there. So sometimes I'll put a little head on my X's just to help me remember it's a person. So each of those little X's represents one student's video games that they have at their house. So for example, this, if I were to look at how many students have 8 video games, I would know that 2 students have 8 video games at home. The least number of video games that my students had were 5, so that means all of my students have at least 5 video games. And the most number that they had was 10. The most video games they had was 10. Not one student had 11 video games. The most they had was 10. Now if you look at the X's, the most common number of video games that my students own is 10. Because 5 students, 1, 2, 3, 4, 5 students own 10 video games. Steps for creating a line plot. Very similar to steps for creating a bar graph or a picture graph. First, you want to formulate your question that you're going to want to investigate. So think of a lot of different questions that you want to investigate. Then design the data investigation to answer that question. Number 3, collect your data. And you can collect data through many different ways: a survey, poll, questionnaire, experiment, or just simply observations. The 4th step is to organize your data by constructing a line plot. So after you've collected the data, you may then start to construct your line plot. And finally, analyze and interpret the data from the graph. This is a really important step. You want to be able to understand what your line plot means. And you want to make sure that the person who's reading and interpreting your data also understands. So that helps you kind of go back and check to make sure you plotted the data properly. So let's look at an example. I have decided to investigate how many chocolate chips were in your cookie. So I asked some students, how many chocolate chips did you find in your cookie? You know I love food. So my data, I went to ask several different students. One student had 12 chocolate chips in their cookie. One student had 10. Another student had 10. 5, 6, 6, 7, 5, 12, 10, 8, 10, 12, and 10. So this is the number that each student counted in their cookie. So let's pretend each student puts their number on a Post-it, and that's how many chocolate chips they found in their cookie. So now I want to construct, after I've collected my data, I want to construct my line plot. So I've already started filling in most of the parts. We can't forget the title, and I titled mine Chocolate Chips Found in Cookies. You want to make sure your title has a really strong meaning as to what the question you are investigating. The data, and we'll wait to put that on in a second. Your number line. Now notice my number line starts at 5 and it ends at 12. I went to my smallest data point that I found was 5, and my largest data point was 12. So I don't need to start my number line any earlier, just at 5, and I don't have to go any further than 12. But I do want each number in between. And I want to make sure that they're properly spaced out. Just like with a bar graph or a pictograph, you want to make sure you have proper spacing so that it's easy to analyze. So I've got my number line, and then of course I need my key. Each X that I'm getting ready to put on is going to represent one student's data or one student's post-it note that they wrote their number of chocolate chips. And then, of course, the label that shows what these numbers mean. These are going to be the number of chips that the students find in their cookie. So let's go ahead and do that. The first student found 12. So I'm going to draw an X to represent that student. The next student found 10. Another student found 10. Another student found 5. There's 2 6s. There's a 7 and a 5. A 12. A 10. An 8 and another 10. A 12 and a 10. Oh, and I need to squeeze this. Maybe I should have put my title up a little higher. Okay, so now it's time to analyze and interpret the data. You want to make sure that this is the point where you check that your data is correct. We've already checked off each student's data. So let's see some different sentences or some different phrases we can figure out just from looking at this line plot. We can see that 5 students had 10 chocolate chips. Okay, let's look closer. We see that 10, okay, the number of chips, 10 chocolate chips, and 1, 2, 3, 4, 5 students had those 10 chips. But you could also maybe accidentally read it as 5 students. You don't want to think that this 5 represents students. Always, always, always the X's represent students. So if you want to draw your little head on your people to help you remember, please do that. You don't want to forget what your data means. You do not want to misinterpret it. So draw your little heads to help you remember. Okay, this says 14 students were surveyed total. Well, in order to get the data of how many students I surveyed, you could count how many of these there are, or you could just go ahead and count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to see if that matches my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good, so I know that 14 students were surveyed. Another interpretation, 5 chips were the least amount of chips found. Well, it looks like 7 and 8 were the least, but again, that is the students. The least amount of students found 7 and 8, but the least amount of chips, this says the least amount of chips found were 5. 2 students found 5 chips, which is the least amount of chips. Or you could look at the most chips found were 12. 3 students found 12 chips. I hope that was me with 12 chocolate chips. And you could say 0 or no students found 9 or 11 chips. Or the most often number found was 10. The most often or the most frequent number was 10 chips because 5 students found 10 chips. Have fun constructing and analyzing your line plots.